Okay, we are still solving equations by graphing. In the last video, you just seen that I graphed both of these equations. So we're trying to solve the absolute value of x plus 1 equals absolute value of 2x minus 4. I set that up as two equations and solved by finding the two x values that are solutions to this equation. All right, so I want you to do the same thing. All right, so you can use your graphing calculator. Hopefully you have something similar. I have a TI-84 plus, hopefully you have a calculator like that or very similar, and you can solve this by graphing. So take a few minutes, do that, and then we will check your solution. All right, hopefully you took time to graph these and find the solutions. Hopefully you found x equals -4 and x equals 0. If you look visually, that should make sense. If you come over 1, 2, 3, 4, -4, you can see that there is an intersection point there. And if you look at x at 0, you can see that there is an intersection there. So hopefully you went into y equals, you graph these, and then once you graph these two equations, all right, you can do second trace. Number 5 is intersection. If you want to find the top intersection, you first have to go to the left of that point, hit enter, come to the right of that point, hit enter one more time, and it shows you the -4. Do the same process again, second trace, intersect. This time you have to scroll down closer to this second point, the intersection point right here. Hit enter, scroll over, hit enter one more time. It shows you that x equals 0 is the intersection. Again, you can check that by going to your second table. You can see that -4 has the same y value on both equations, and 0 has the same y value for both equations as well. So -4 and 0 are your two solutions, your two x values, your two x-intercepts. Whether or not the x-intercepts this time, they're just the solutions for this equation. All right, two more questions that I want you to do yourself and think about, kind of a self-assessment to see if you're understanding what we're working on. So this question says the graphs of the equation y equals absolute value of x minus 1 and y equals 3 intersect at the points -4, 3 and 4, 3. Without solving, find the solution of the equation absolute value of x minus 1 equals 3. So again, they took this, set it equal to this, explain your reasoning. So this is going to be your f of x equals g of x. What is the solution, and can you find that without graphing or without solving? Okay, hopefully you took a minute to do that and you come up with x equals -4 and x equals 4. Your x coordinates are your solutions. So hopefully you found that. Hopefully you understand why the x coordinate is the solution. If not, maybe go back and review the previous video or reach out and ask some questions. All right, this question says, consider the graphs shown. Okay, you have two graphs here. Write an equation in one variable with solutions that are the x coordinates of the intersection points of the graphs. Given an equation with an absolute value expression on one side and a linear expression on the other side, you can see that one is a V shape, so you know that's absolute value, and you can see that one is a line, so you know that should be the linear equation. So it says, given an equation of an absolute value expression on one side and a linear expression on the other side, how many solutions can the equation have? Explain your reasoning. All right, so pause the video, take a minute to solve this, and then we'll check your answer. All right, hopefully you took time to answer this. A part shouldn't have been very hard. It says write an equation in one variable with solutions that are x coordinates of the intersection points of the graph. So you know that you've got f of x equals g of x. So all you had to do was take this equation, set it equal to this equation. So it doesn't matter which one you put on the left or the right side. You should have something similar to this. All right, B part. I love this question. This question makes you think a little bit about different scenarios. So it says, given an equation with an absolute value expression on one side and a linear expression on the other side. How many solutions can the equation have? Explain your reasoning. All right, so it could have 0 solutions. So let's say I have an absolute value equation here, and then I have a linear equation out here that has the same slope as this absolute value, so these would never touch. So you could have an absolute value and a linear that has no solution, that they never touch. Maybe the linear equation has the same slope of one of the lines on the absolute value. All right, they also could have one solution. Let's say the linear equation is a line that comes straight across and hits one time of the vertex, at the vertex for the absolute value. So in that case, they would have one point of intersection, they would have one solution. All right, it also can have 2 solutions as shown here. The linear equation, the line goes through both sides of the absolute value equation, so it could have 2 solutions. And then it could have infinitely many. Let's say that this red line is changed, it's shifted up a little bit and has a slope of 1, and it would have the same y-intercept of 2, then the line would be right on top of this part of the absolute value. So if that was the case, every point that overlapped on this line and the linear line would be a solution, and that would be infinitely many. So that's your explanation. So how many solutions? It can have 0, it can have 1, it could have 2, or it could have infinitely many for all the reasons that I just explained. All right, example 3. You are studying 2 glaciers. In 2020, Glacier A had an area of about 40 square miles and Glacier B had an area of about 32 square miles. You estimate that Glacier A will melt at a rate of 2 square miles per decade and Glacier B will melt at a rate of 0.25 square miles per decade. In what year will the area of the glaciers be the same? All right, so let's think about what we're trying to do. All right, so we know that we have a glacier, we have the area of Glacier A and B in the year 2020. All right, so in 2020, Glacier A has an area of about 40 square miles and Glacier B has an area of about 32 square miles. All right, so we know we can take that area and we can subtract the area lost per decade. So it says 2 square miles per decade. That's Glacier A. Remember, a decade is every 10 years. And Glacier B will melt at a rate of 0.25 square miles per decade, or every 10 years. So it says, in what year will the areas of the glaciers be the same? All right, so if we do what we know, we have to set up an equation. All right, so let's look at Glacier A first. So we can say Glacier A, we're going to have y equals, we're going to have 40 square miles to start with, and then we're going to subtract 2 square miles per decade, okay? And we don't really know how many decades right now it's going to be before these two are equal. So we're just going to say x. All right, and then our second equation, we're going to do Glacier B. Glacier B starts out with an area of 32 square miles. And then it's going to melt at a rate of 0.25 square miles per decade. So we're going to minus 0.25x. Again, x just represents the time per decade. We don't know what the time's going to be yet, so we got to find that intersection point to solve that. So we can set this up like the equations we've had. 40 minus 2x equals 32 minus 0.25x. All right, so to solve this equation, we can set these two in our calculator. All right, so let's go to our calculator and say, all right, we've got 40 minus 2x, and then we're going to have 32 minus 0.25x. And then if you notice these numbers here, 40 and 32, those are your y-intercepts. A normal graph is going to graph on 10 by 10. If you can't see anything, you've got to change your window. So if we go to our window here, we want to change our y values, because we know that this is our slope, right? And this is our y-intercept. It's good to know what part of the equation you're looking at. We don't need to go very far down, so we don't need negatives, but we do need to be 40 or above. So let's just choose 42. That's slightly above our y-intercept of 40. Now when we hit graph, we should see the lines show up on the graph. And if for some reason you still couldn't see the intersection point, you may need to expand your graph a little bit more. All right, so it looks like our graph is going to intersect here around x equals 4 or 5. So let's go second, trace. Let's do number 5, intersect. Scroll down, hit enter, scroll over, hit enter again, and this says they're going to intersect about 4.57. Okay, so we have x equals 4.57. That's our x value, but this says in what year will the areas of the glaciers be the same? So if you remember, it says in 2020, Glacier A has an area of this. So we're starting in year 2020, and we've went 4.57 decades. Remember, this is in decades. It melted at a rate of 2 square miles per decade. Glacier B melted at 0.25 square miles per decade. So x equals the amount of time in decades that went by. So let's take and look at this. Let's think about what we need. All right, so let's say we've got year 2020. And in year 2020, we're going to add 4.57, but we know that's times 10 because a decade is 10 years. All right, so that's going to give us the starting year plus our 4.57 times 10, our decade. So 4.5 decades. So this is going to be 65.7. That would round up to about the year 2066. So in the year 2066, then you would say that the area of the glaciers will be about the same. All right, so again, just real quickly, all right, we wrote our equations based on the information given. It's straight from the problem. Glacier A had an area of 40 square miles. Glacier B had an area of 32 square miles. Those were our y-intercept numbers here. You estimate Glacier A will melt at a rate. Melt means it's going down, so that's why we subtract 2 times x. X is the amount of time it takes, and we don't know what that amount of time is till we solve it. You estimate Glacier A to melt at 2 square miles per decade, Glacier B to melt at a rate of 0.25 square miles per decade. Again, it's melting, so it's going to be subtract 0.25x. We can set these two equations equal. That's just the same as having f of x equals g of x. We solve by putting these two in the graphing calculator, finding the intersection point. The intersection point was about x equals 4.57 years, or decades, sorry, 4.57 decades. We are talking about decades here. And then this number represents the year the area of the glaciers will be the same. And we found that by taking the year 2020 and adding 4.5 decades to that. So 4.57 times 10 represents a decade, remember. So 2020 plus 4.57 decades is going to be about the year 2066. And in that year, the glaciers will have approximately the same area. All right, if you have any questions, please let me know.